Hey everyone. In this video, we're going to have some fun with wildcard masks and Cisco access lists, and we're going to do some fun, traffic filtering on those access lists. So, what we're going to do specifically is I have this really simple lab here. All the routers are connected with EIGRP, and what we're going to do is focus on the routing table of router 3. Right now, router 1 is sending a ton of routes to 2, which is just sending a ton of routes to 3. What we want to do is use some access list filtering on 2 to either filter out all the odd routes or filter out all the even routes, and specifically the odd or even in the third octet only. All right? So we're given a task, and we'll start by filtering out all the odd. So we'll just say we're going to filter out all the odd routes in the third octet. I'll show you the routing table to show you what I mean, and we'll get this configured. And then I'll configure the odd one. I'll show you how it works and make sure you really understand it. And then we'll go ahead and configure the even one. So router 3, let's do a show IP route EIGRP. And we can see that we have all these 10-0 routes from 1 all the way to 12. So the first thing we're going to do is we're going to filter out all the odd routes. So 10-01, 10-03, 10-05, and allow the even routes through. So in order to do that, we're going to head over to router 2. And let's first configure an access list. I'll just say access list 1. It doesn't really matter. We're going to permit 0000, 255, 255, 254, 255. All right, I'll explain that in a moment in case you're kind of confused, but I just want to show you how it works first. Let me go into router EIGRP. Address IPv4 AS100, topology base. We're going to do a distribute list. Distribute list 1, and then we'll do it to from our link from us to 3 out. Did I not get the command right? Hold on. Sorry. Out. Gig 03. Got it backwards. Okay. So now let's head over to 3. And it did not work. Oh, it just resynced. Sorry, I just took a moment. You see this dual EIGRP neighbor resynced. So now let's look. And sure enough, in the routing table now, we have the 1002, 1004, 1006, 8, 10, 12. But we no longer have any of those odd routes. So we filtered out the odds, allowed the even. So how does that work? All right. So think about what you know about a wildcard mask. All right. Let me bring up a pen. We're basically doing a binary match. Okay. If it's a 0, if the bit is a 0, then that means it has to match. Okay? And if it's a 1, it means that we don't care. I'm just going to put DK or DC. Don't care. So if we look at these 4 octets, 255 is all ones. So we can represent that with 1, 2, 3, 4, 5, 6, 7, 8. That means that any bit in that octet, we don't really care. We're going to let it through. So for this octet, doesn't matter what it is. This octet, doesn't matter what it is. And the final octet, doesn't matter. So we're going to allow any route that has these, and that. This one is a little bit different. The third octet. So what's going on in the third octet? Let's get rid of this. Okay. So I'm going to just go 1, 2, 3, 4, 5, 6, 7, 8. So remember what we know, that 0 means it must match and 1 means it doesn't have to match. Okay? So 254 in binary is 1, 2, 3, 4, 5, 6, 7, 0. That means in the first 7 of these bits, we do not care about the match. Okay? It doesn't matter. These numbers can be anything. But in this final octet, it has to match. What does it have to match? Well, it has to match this 0 right here. So a 0 in binary is obviously all zeros. Right? So that means that any number in this third octet has to have a 0 as the final bit. So now, knowing what we know about binary, I'm sure you haven't made it this far if you if you don't know anything about binary. But what we know about binary is that if any number has a 0 in this final bit, which is 1, then it's an even number, right? Because if it had a 1 here, it would be an odd number, because we know it's 1, 2, 4, 8, 16, 32, 64, right? So since this is 0, that means it has to be an even number. So that's why we're allowing even numbers all through there, right? So it's 254. If that doesn't make any sense to you, think about this. How would we turn this into matching all of the matching all of the odd numbers, right? So what we would do is, instead of having a 0 in this octet, if it was a 1, then again, it doesn't matter what these numbers are, but if we had a 1 here, any number that comes in with a 1 in this final bit would be matched as an odd number. And we can prove that pretty easily. So let's go ahead and reconfigure this access list. So let's say no access list 1. All right. Instead, we'll access list 1 permit 0010 255 255 254 255. Okay. Now we just resynced, which means on R3 we probably have all the routes back. Which we do have all the routes. Give it a minute to resync. Now that I put here. Okay, it resynced again now that I put in this access list. Now we permitted all the odd, but we blocked all the even. Right? So with this access list here now, permit 0010255, and I'm sorry. Oh, here it's up here. Better. 255, 254, right? So we're permitting everything that matches this. Oh, actually, no, that's the. I'm sorry. This. Here we go. All right. So again, to talk you through it, what this means now is that in the third octet, we have a 1. So that means it's 1, 2, 3, 4, 5, 6, 7, 1. And then the third octet here is 1, 1, 1, 1, 1, 1, 1, 0. Meaning we don't really care what's in these. Does not matter. But what does matter is that that final bit has to equal a 1. So it doesn't matter what kind of number it is. As long as that final bit is a 1, we're allowing it through. So I hope this was clear. I know binary is annoying, but it's part of the life of being a network engineer is really understanding this. This particular situation, you may think, why would I ever do this in prod? But I've certainly worked in environments where the IP addressing scheme is, if the second octet has this number in it, then it's from this building. If it has this number, it's from that building. So your IP addressing scheme may not be perfect depending on how people engineered or designed the network. So really good to know how wildcard masks work and how you can use them not only discontiguously, but use them to do interesting things. So thanks for watching. I hope you enjoyed the video, and we'll see you on the next one.